If you look at this problem here, example 5, you'll notice it looks very much like what we did yesterday, right?
Yes.
Okay, because it's the same kind of problem. It's a nonlinear system of equations. The ones we got yesterday were factorable expressions. They were rational solutions. The constant disappeared, so we had x common factor taken out, so it was pretty straightforward and easy. This one's not going to be as straightforward and easy, but I think we'll still be able to handle it. So the technique that we did yesterday is the same. These don't match, so elimination's off the table. We can't use elimination. I have to use substitution. I do have options on substitution. I either get to say y equals or x equals pretty easily, right? I'm thinking moving x to this side might be the best plan, so y equals x plus 1. I could have also put x here and 1 there, so x equals y minus 1. Again, it doesn't matter which one you get to say it, just as long as you get one of the letters equals something else. That's the key. And if y is equal to x plus 1, that means x plus 1 can be replaced for that y up there. So the top equation gets transformed into x squared plus x plus 1 squared equals 9. So that's the first thing we want to do. Okay. By doing that, I've changed this equation with x squared and y squared equals 9, two variables, into x squared, x plus 1 squared equals 9, one variable. So that has a single variable, so it can be solved using whatever technique. And again, it's very often that y is getting replaced with multiple objects. Make sure the multiple objects get put in parentheses. Okay, so that entire parentheses is being squared. So x squared plus, and then again, just like yesterday, we have a binomial squared. We use our little shortcut. X squared plus 2x plus 1 equals 9. All right, same shortcut we use every single time. And at this point, I got a quadratic equation, so equals 0 is important. So I'm going to move the 9 over here. Getting ahead of myself there. Move the 9 over there, like so. So it equals 0. Anytime you have x squared and x squared is not going to go away, equals 0 is going to be your best friend. So make sure you make that happen. If I go ahead and add everything together, I can. X squared plus x squared makes 2x squared. Then I got a plus 2x and a minus 8. And everything there is even, so dividing by 2 is legal. You're not required to do that, but it's worth doing. Okay. The final thing I got to do now is I got to solve this x squared plus x minus 4 equals 0. So again, looking at factoring first as a possibility. All right. Two numbers multiply to make negative 4, then add to make 1, and I'll give you 50 cents if you can do it. No. All right. You can't do it, right?
We can do this.
No, two integers. I should say two integers. There are two irrational numbers out there that do it, but yeah, so you can't do it. So what I want to do then, if it's not factorables, I want to resort to the quadratic formula. I know that a is equal to 1, b is equal to 1, and c is equal to negative 4. Keep in mind what letter we have down there is x, right? So what we're doing with the quadratic formula is we're getting x equals. Get in the habit of writing x equals when you use the quadratic formula, or y equals, whichever one you're trying to find. Right? Don't just do the quadratic formula, you don't have a letter next to it, otherwise you're just going to get an answer that's a number, and what does that number represent? So this is x, so this is x. Minus b is negative 1, 2 times a is 2. Change the sign, double the number. B squared minus 4ac is going to be 1 minus 4 times 1 times negative 4, which is 1 plus 16, which is 17. Now, once you get to this point, that's the answers for x. The plus or minus, plus or minus. That's the answers for x, right? So, plus square root of 17 is one of the answers, minus the square root of 17 is the other one. I want you to get decimal approximations for these. Not that it's impossible to work with that number. In order to get y, I have to add 1 to this. All right? Give me a decimal approximation. That's what I want on these problems. The back of the book has the radical expressions. I don't want the back of the book answer. I want decimal approximations. So the way you type this in your calculator is parentheses, negative 1 plus the square root 17, m parentheses for the square root, m parentheses for the top, divided by 2. That's how you type it in. Okay, so negative 1 plus the square root of 17, n parentheses for the square root, m parentheses for the top, divided by 2 equals, and that's 1.56. Then, I'm going to type in negative 1 minus the square root of 17, n parentheses for the radical, m parentheses for the top, divided by 2. And that comes out to negative 2.56. So negative 2.56, positive 1.56 are the values for x, right? So my ordered pairs are going to be x first, 1.56 comma something, and negative 2.56 comma something. Okay, again, you get two answers for x. Those are the x coordinates for your answers. The y coordinates are found using this fact. We're supposed to add 1 to whatever x is, right? X is 1.56, what's y? 2.56, right? By all means, if it's just plus 1, I believe you can add 1 in your head. I don't need you to have it written down in your paper. All right, negative 2.56 plus 1 is negative 1.56. I will believe that you did that in your head. You don't have to show your work on that. But y equals 1.56 plus 1. You know, that's fine. Y equals negative 2.56 plus 1. By all means, if you want to leave this off your paper, that's fine. But all the rest of this work is pretty much necessary to get these two answers. I'd expect your paper to look a lot like that. Showing me absolutely no work and getting me answers that look like this. Negative 1 plus the square root of 17 over 2, comma 1 plus the square root of 17 over 2. And negative 1 minus the square root of 17 over 2, comma 1 minus the square root of 17 over 2. So imagine this is, let me just grab this real quick. I don't know, let's just say this is number 17. There's your homework paper. Boom. Not quite. You didn't do the problem. You copied it out of the back of the book, you wasted both of our time. Please do this, give me decimal approximations for your answers. I expect to see where the substitution happened, I expect to see where the quadratic formula happened, I expect to see where you've evaluated. You don't have to necessarily write down what you typed in your calculator, but I expect to see this, which translates to this. And then again, if you have a more complicated expression, then maybe if you write it out plus 1, I believe you can have 1 in your head. But copying it out of the back of the book, it's not helping you become a better math student. So, and it's making me have to explain the process to you again because you haven't practiced it. And that's wasting my time down the road. It's wasting your time because you had to write something on your paper that didn't get credit. So do your work, go through the process, become better math students. Okay.